Hello, students. Very good morning to all. Actually, today the topic is quantum superposition that we are going to see. So, one by one, slowly, we'll discuss about this concept. Actually, this concept is very important and a fundamental topic in the quantum mechanics. That is a superposition. First, we should see the definitions of the superposition. So it is a fundamental principle, as I earlier said. It's a fundamental principle of the quantum mechanics. In this, the particular quantum systems will exist in the multiple possible states at the same time until it is observed or measured. Up to the measurement, the multiple possible systems or states available at the same time. So this is a simple definition for the superposition. So, what is the exact core ideas behind the superposition that we need to see? In a classical systems, exist in one definite states, uh, but the quantum systems will not be like that. So here, these quantum systems are basically described by the wave functions. So mathematically, we can express that systems for the superposition like this. Simply, the mathematical object that contains all possible states and their associated probabilities. Simply, we can express that superposition concept. So this is a mathematical expression for explaining about the superposition. You see here, kit 0 and kit 1. So both represents the states, quantum states. Kit 0, we may consider it in one state. Kit 1 is opposite state. Uh, in the case of the superposition, kit psi, the both states are possible. And here the C naught and the C1 is nothing. Both are the complex numbers, which may called as probability amplitudes. Then what about the key features about those matters that we need to see? The key features in terms of in the perspective of the probability distribution, if you see, this will be it represents, that means the C naught square, the probability amplitudes, this C naught and the C1. That C naught square and C1 square both represents the probabilities of the finding the systems of both ket 0 and ket 1. C naught square, which represents the probability of finding the system in the state ket 0, and the C1 square represents for the ket 1 upon the measurement. So upon the measurement, we can identify the exact amplitudes or magnitudes of the probability of finding the system either 0 or 1. And one more important feature is collapse on measurement. I mean, superposition will be there up to the measurement. So when you observe that superposition system will collapse into one definite state, means we are destroying the superposition. And another one point is the interference effect. The superposition will make one new effect, that effect called as a interference. The different probability amplitudes can add or cancel out, producing the observable interference patterns. So these are all the general key features on the superpositions. So now we need to see the example for, available example for this superposition. Famously, from our earlier classes, olden age class, The famous example for the superposition is a double slit experiment. In the even 11th and 12th standard also you can study this concept. So double slit experiment is one of the example for thinking about uh, superposition. So electrons or photons which can create the interference patterns, which prove the existence of the superposition along with their paths. See, one of the important feature of the superposition is interference. That interference we may create by using this double slit experiment. So that interference is possible only due to the superposition of the uh, constructive, I mean, waves. I mean, constructive interference, destructive interference, both will possible in the case of the superposition of the waves of the crust like that we are studying now. So the superposition of the states of the waves. And another one famous example for this superposition is the Schrodinger's cat. So which was introduced by the Schrodinger in a very famous way. Um, a thought experiment showing a cat in a box that is simultaneously alive and dead until observed. This is very famous one. So these two are very famous example. Now we need to think about the how this superposition state is important in the quantum computing. Actually, the superposition allows a single quantum bit, I mean qubit, to represent the multiple values at once, enabling massive parallel processing power. This is important. This is the point. The qubit, uh, we have the states, zero state, get zero state, get one state. Like that, the superposition state is also one of the state in the, for the qubit. So that superposition state is to represent the multiple values at once, enabling the massive parallel processing power. So this is a general ideas and features and examples and for the superposition topic and how this superposition stop concept will uh, important in the quantum computing that also so we mentioned it here. So based on these concepts, now we can discuss the further concepts about the entanglement and the different the gate concept all one by one. So thank you, students. So we will meet the next topic in the next class. Thank you. Thank you so much.